Good morning, ladies and gentlemen. Good morning on site. And it is echoing still? Okay. And good morning also online. Thank you for joining us this morning on Expanding Scientific Frontiers with International Scientific Networking, with the presence of the National Science Foundation AccelNet program, as well as the COST program from the European Union. I have the pleasure to have welcome speeches to be given by two distinguished leaders. And I would like to ask Ronald O'Brien, the director of the COST Association, to give his welcome to you. Ronald.
Thank you, Kata, and also Kara. Kata and Kara, thank you so much for organizing this and letting us do, let's say, the ceremonial part, which is always the easy part. And it's a great pleasure to see you all here. I understand we also have people connected remotely, so we are with many more people than just, you here in the room. And I've been told that also our colleagues in COST are on the live stream all together. So also the COST colleagues in Brussels, very nice for you to connect. And now let's get a little bit to the essence of why we are here today, because the focus of today is international science collaboration through networking. And we have the National Science Foundation here, in particular the AccelNet program of the United States and the European COST, let's say, program. And it's the first, I would say, encounter. And we already had a chat, I think, and immediately we got to the same level of understanding and about networking and of course also the benefits of building science networks to tackle the challenges, because we can build synergies, we can have exchanges, people from different types of disciplines coming together, and with that we can hopefully also foster some breakthroughs. Few words about COST. COST, by the way, ladies and gentlemen, don't be confused, is a benefit. Doesn't cost you anything. Stands for European Cooperation in Science and Technology. We, since 1971, are an intergovernmental organization, currently including 43 countries that are member of COST. These are European countries, but it's not just the European Union, because that's 27. Our geographical footprint is much larger than the European Union countries. And we have a couple of, let's say, strategic objectives. First and foremost is that we promote and spread excellence across the networks. We foster multidisciplinary research, as I just mentioned, for breakthroughs. But last and certainly not least, we try to boost the careers and also the retention of young researchers' careers in the world. Now, having said that, 43 countries, members, but COST is open to the world. That means that if you go to a networking, let's say, event, typically talk about conferences or training schools or even individual short-term mobilities, COST can fund your expenditures. So that's very nice. And it also applies to the countries, let's say, around the geographical footprint of COST, particularly in the Northern African rim. We call them now near neighbors. Also, these countries, researchers, communities can participate in COST and get their expenditures reimbursed. And we just exchanged a little bit of ideas and on that. Of course, COST is open to everyone in the world. You do not even have to have submitted a proposal. You can knock on the door of the chair of a COST action, and we will listen very carefully in a moment. And then you can actually participate. But you have to bear your own expenditures. And if you have funding for that, this would really be, let's say, an asset to the network, because the value, of course, is in the number of connections and the quality, of course, of the connections. So COST, in that sense, opens a call for proposal, and once a year we empty the bucket. It's completely bottom up. We do not prescribe any thematic, let's say, topic. Everyone can contribute, but you have to have at least 7 countries submitting it, out of which 3 have to be, and that's part of our policy, from less research intensive countries. That's across the membership of COST. However, we select proposals predominantly on the basis of excellence. And this year, actually, as I'm speaking now, we are kicking off new cost actions, 70. We have around 300 in total that we finance. And these actions are meeting for the first time. And we have a network of national coordinators that nominate people from their communities to participate. So we start with excellence, but at the same time, we're also super inclusive without having to submit a proposal. That's what we call the inclusive excellence principle of COST. Now, that said, I think for today, we are here to listen to very interesting stories. I think a very profound success story. We will hear from our keynote speaker on black holes, or the image of a black hole, or how this was done, because I don't think you can see a black hole with the naked eye. At least I tried, but I didn't see. I saw a lot of black and a lot of stars, but not any holes. So be very interested in that. But we'll also have a roundtable discussion, also allowing some insights and understanding the benefits of the two funding programs. So without much further ado, I, from my side at least, would like to thank you so much for being with us today. And we hope that you can appreciate, let's say, our further exploration in building the cross-Atlantic ties in science networking to the benefit of our community. So thank you so much. I'm looking forward to a fruitful debate.
Good morning, everyone. I'm here on behalf of the U.S. National Science Foundation. My name is Ann Emig, and I'm the Section Chief for Programs and Analysis. So our EU cost counterpart program for the purposes of this meeting is our AccelNet program, Accelerating Research Through International Network-to-Network Collaboration. So, so I would like to start by first to Dr. De Bruin and the EU cost team, to my NSF colleagues and our partners at the CUNY Graduate Center, and to the researchers and friends who are gathered in person and online. We'd like to welcome you to this important event. We're honored to co-host this event within the Science Summit to raise awareness of the impact of international research collaboration on addressing critical challenges in global science, including contributing to realization of the UN Sustainable Development Goals. At NSF, we believe with every fiber of our being that basic research is critical to advancing national well-being and global well-being. We see global scientific cooperation and exchange as a critical way to leverage resources and to share expertise and lower the barriers to solving grand challenges. And the stickier the problem, in essence, the more important the global collaboration is. For us at NSF, we are fundamentally a bottom-up basic research and STEM education funding agency. And our bread and butter work is individual investigator-driven research proposals. But over the last 15 to 20 years, the agency has come to appreciate that we're funding an awful lot of research and data collection and things like that in related areas. Not exactly the same, but with a lot of synergies. And it may be interdisciplinary, it may be within the same discipline. So we felt that in order to fully realize the impact of a large number of individual investigator awards, we needed to proactively pursue some network building opportunities. So this started with more of a domestic focus at first through a program called Research Coordination Networks. Then, so RCNs would bring together 5 to 10 PIs in a given field. They'd exchange data, methods help set priorities for research that remained to be done. But over time, they realized that in very few areas of science was the relevant work done only in the US. And there was a gap in programs that offered an opportunity for US networks to engage with networks outside of the US. So in 2018, we began this program, AccelNet, Accelerating Research Through International Network-to-Network Collaboration. We began in the first year with a series of community building workshops to try to develop some understanding of what was necessary to effective network science. Then in 2019, we issued our first call for proposals, and we've been pleased to be funding a dozen or so awards since then. Unfortunately, a year into the program, COVID hit, which meant that the international networking opportunities suddenly became highly virtual. But I think our teams found ways to use that time as well, in addition to on the ground meetings and collaborations when the public health situation allowed. Let's see. So what we have seen is that that our network of network opportunities bring people together in workshops, in summer schools, in short-term exchanges, in a whole variety of different meetings. Many of the networks begin with fundamental challenges related to data sharing, but it's not exclusively that. The activities or the focus of the networks are as diverse as the topics covered. And our hope and our strong belief is this network to network collaboration creates a situation where 2 + 2 equals far more than 4. And that it's not just a linear progression, that there are all sorts of creative ideas that come from building these networks of networks and building them out over time. Need to put my glasses on so I can see what I wrote. Okay, so to not take up too much time, I just say in closing, I'd like to thank Dr. De Bruin and Kata Al-Fadi and our EU cost team colleagues, Professor Tom McGovern and Ellen Doriso from the CUNY system, and Dr. Kara Hoover, from my NSF colleague. I would like to thank you for having the vision to organize this important meeting and the commitment to see it through. I suspect there were some rough moments along the way. I look forward to rich discussion throughout the day, and I'm excited that this event has really created an opportunity for NSF and EU costs to deepen our collaborations as well. Thank you for your time, and I look forward to the rest of the day.
Thank you very much for all the welcoming address and the nice words and the encouraging thoughts. And now this is my pleasure to invite Professor Luciano Rezzolla.
Sky is inevitably very, very small. So black holes are terribly small objects when they are projected on the sky. And of course, you want to take a picture. That means they must be resolvable. You must have an experiment or a photo camera that is able to see such a small object. And we know that with the best technology today, we can use and reach a resolution of about 10 microarseconds. Just to give you an idea, it's like trying to see a coin on the surface of the moon. Okay, that's the kind of size we're trying to get. And you would think, well, okay, if I want to solve this problem, I need to have very big black holes and them as close as possible to us. And you find out there are two perfect candidates for this. One is M87 star, and the other one is in our galaxy, and it's Sagittarius A star. And you also need another important technique, and it's called VLBI, or Very Large Baseline Interferometry. This is a technique which I will try to explain very quickly now. So there is, if you study ever astronomy, the first thing you learn is that if you want to take an observation, you need a resolution. And the resolution is essentially given by the wavelength at which you're taking the observation and the size of the telescope you're taking the observation at. Now, as I said, we want a resolution of 10 microarcseconds, and the wavelength we want to have is about a few millimeters, 1.3 millimeters. That's because those wavelengths, those waves will reach us without being absorbed between what is between us and the black holes. So if you use this expression, a very simple expression, and you put on the left-hand side 10 microseconds, on the right-hand side you put 1.3 millimeters, you find out that the size of the telescope you need is as big as the Earth, okay? Something which is of a few thousand kilometers. Now, as you can imagine, building a telescope of a couple of 1,000 kilometers is not easy. But here is where this technique comes in our help. The idea is that take a lot of small telescope, radio telescope, 30, 40, 50 meter in diameter, which are scattered across the planet, and put them together. How do you put them together? Well, through this technique, which is called interferometry. And so you can imagine of having two telescopes, say one in Arizona and one in Hawaii, and all of a sudden you have a virtual telescope which is as big as the distance between these two. And well, you know, we have more. As you can put two in connection, you can put 3 or maybe 8. And that's what we've done with the Event Horizon Telescope. We put together all of these telescopes so that we have a virtual, very large telescope. And this telescope can cover the observations because the Earth is moving. And as it is moving, there's always going to be a combination of telescopes that can see the source. Now, if you think a little bit about what I just said, you start thinking that there is something fishy about this. How do you actually do this, right? Why can't we do this with everything else? And the reason is that you have, in order to be able to do interferometry, you have to make sure that you are really observing the same wavefront, the same electromagnetic wave. And that is why every of these telescopes is also equipped with a very accurate clock, an atomic clock, which measures not only the intensity of the field that arrives, but also the time. And only then you can synchronize the telescope and make sure you're really observing the same object. So this is, in essence, the technique. And let me just try to give you some example. This is, some telescopes that have been used as they are scattered across the planet. You can see they are everywhere. This is an example of international collaboration. As the planet moves, it collects data, produces what we call tracks in this Fourier space of the visibility amplitudes, and out of this you can build, out of this information that you see in the middle panel, an image. And as the Earth rotates and the tracks become larger and you can fill more this space of information, you obtain a sharper picture. Okay, that's the basic idea. And you can see this now with actual data. At the beginning, there are very few telescopes. The data is very sparse, but as time goes on, you can build more and more data, and you can start having a picture of what a black hole looks like. And now, in order to do this, you need a critical mass. Okay, I think it's clear that in order to perform such measurement, is not easy. You need, first of all, to coordinate telescopes to be able to take observations with a precision of a nanosecond, and this means having extreme skills and decade-long experience. VLBI is a bit of a black magic. You really have to work a lot of years in order to be able to an expert in this. But you also need not only to collect the data, you also have to understand the data. You have to interpret, you have to make predictions. So there is an observational challenge and there is a theoretical challenge. And all of this is possible only if you have a critical mass, only if you have a sufficient number of neurons, that is a sufficient number of humans that work all with the same goal of obtaining, for instance, an image of a black hole. And this is where networking is essential, okay? In modern physics or in modern science, breakthrough results necessarily require the cooperation of many, many minds. And I would say something more about this also later on. Now, this is an example of this networking. This is, what this meant as people went in and collected the data at these various telescopes. And as you can see, they're all pretty happy. They're all showing smiling faces. And the reason is that when we took the observations, there was good weather. You could see there is sun everywhere in those telescopes. And this is very important to us because water vapor is a killer. if there is a cloud just 3 kilometers above your telescope is unable to get any information. So everybody was smiling because it was perfect weather conditions and we could get the data. And in 2019, we published the first image. The day after, this is the first pages of all the newspapers in the world. It's been calculated that 4.2 billion people have seen the image in about 24 hours. That meant that either, unless you were living in a cave or where you're completely drunk, you must have seen the image right after it was published. And we think it's also because this was, an inspiration for social media that really helped interpret what we were actually seeing, which wasn't clear to us. Now, I am a theorist. I didn't do any of these observations. I hardly understand how things work. But I was tasked with trying to explain them. And I will try to explain to you now why what we see looks exactly like that. That's what my colleagues had asked me. So this is what we see. Explain why it looks so funny. And in order to do this, you essentially need 3 steps, 3 logical steps. The first one is what we call in our jargon, general relativistic magneto-hydrodynamic simulations in curved spacetime. Essentially, you have to learn what happens to a bucket of plasma which is thrown onto a black hole. The second part is understanding the ray tracing, the radiative transfer that produces the images. Again, to be a bit simpler, imagine this bucket of plasma that is thrown. This is going to be accelerated, compressed, heated up, and will emit light, in particular synchrotron emission. And then you have to understand how light is emitted. And this is far less trivial than you imagine. And I will explain why. And then you can produce lots of theoretical images. I will explain this is not easy, but then you have to compare with a few observations that we have. Okay, so let me start with the first step, the plasma dynamics. This is a simulation that has been done in my group, showing what happens to this bucket of water. We don't start with a bucket, we start with what is an axisymmetric torus, which then accretes as a result of an instability. It's magnetized plasma. There is an instability that produces this very large magnetic field, which is shown in blue and white in your screen, and the red, yellow instead shows the density of the matter. And as you can see, as the animation will start again, the accretion is a very stochastic process. This is because an instability is driving it, and it's a bit like being next to a waterfall. You will see that there is a steady stream of water, but really there are fluctuations. And these fluctuations lead to local changes in temperature and density, and of course, this with different images. And this is the inclination at which we think we're seeing M87. So there is a jet which is coming almost towards us. And now you have to imagine that you wear radio-sensitive glasses, and that's what you would see. That's exactly the same matter that I was showing you before, but now in terms of intensity, the emission that it produces. And as you can see, it's almost a ring. And this is a bit deceiving because this ring is actually very complicated, has a very funny shape. And you realize this when the ring is not perfectly aligned with respect to you. And this is the way that ring would look like with the telescope. Don't forget, telescopes have a finite resolution, so even the very fine detail will be lost. And the variability that I'm showing you here is of the order of a few days. And that's what we've seen, okay? So you can see how from basic principles and going through these steps I was telling you, you can understand how an object like that looks like. Now, I mentioned that tracing photos is not easy. You all know how a laser pointer works, okay? A laser pointer, press a button and up comes a nice little green spot. That's because we are in a flat space-time. And light moves on a straight line. But near a black hole, light can have very funny behavior. And here is an example. Suppose that you have a black hole and you have a thin disk of matter, which is also producing radiation. And you want to take a photo, say a photographic plate with a given inclination. What you will see, you will first get all the photons that come right from the face, the front face of the disk. And you can see that it's that layer over there. But there are going to be photons that, in principle, you should not be able to see. The ones behind the black hole, but because the space-time is curved, those light photons will actually reach you. And that's why you see the second part of the disk. And to make it even more complicated, you can also see the lower sheet of the disk. And that's what you see over there. Now, I don't know if you are a science fiction fan, but you probably have seen this image. This comes from Interstellar. This is when the spaceship is getting close to this supermassive black hole. And this is a pretty decent representation of what a black hole would look like. And fundamentally, it teaches you an important lesson. If you have to hide, don't go behind a black hole. It will not help. Now, which black hole and what are the conditions around a black hole? I may have given you the wrong impression that we know what is near a black hole. Actually, we don't. We have just a very vague idea, because if you look at a black hole, the closest black hole we have in our galaxy, we have a very unclear picture of what are the physical conditions. You may expect that matter follows the accretion disk of the type I've given you, and there are reasons why it should look exactly as I've shown you, but we are not certain. So in our analysis, we really had to be as agnostic as possible. And for this meant that we had to do a lot of simulations with all the possible conditions, with all the possible types of black holes we know of, different types of accretion flows, and so on. And this means that together, different groups that have teamed up in about 1 year have explored this process of black hole accretion more extensively and accurately than over the last 3 decades. So this is an example of a library of images that you can produce out of these simulations. We had to run many, many, many simulations. About half of them were run in Frankfurt. And you can see that there are, black holes that go in one direction, black holes that go in the other direction, very bright shadows, very small shadows, and so on and so forth. This is just to give you an idea that there is a large uncertainty because we don't know exactly what are the physical conditions. And as scientists, you have to be as agnostic and unbiased as possible. So out of this, you build then millions of virtual images. These are images that are mathematically, physically consistent, but not necessarily matching reality. Reality has given us 4 images, and we had to compare them with the theory. So how do you do this? Well, it's very simple. Imagine you are in a stadium, and in a stadium there are about 60,000 people. Okay, and you have a picture like the one on the left, and you would like to know if this person is in the stadium. You go to the security manager and ask exactly this question, and the security manager will tell you, yes, of course, just wait a second. And he runs his software and compares the image that you've given him with all the images of all the people that are in the stadium. And then he, at the end of this process, he says, there you go, here is the answer. And you say, well, so what is the answer? Is this person in or not? And you say, well, obviously you don't know physics. This is the answer I can give you. I can tell you that there is a distribution of images that matches with a given tolerance, the ones you've given me. And so these people are those in the stadium, and I don't know if that person is in that. And that's exactly what we have also learned. But you see, already with this rather vague knowledge, we've learned something very important, that the person we're looking for is most likely a woman, because all of the selected images are those of women, and that has long hair, because all, again, the sample that returns are all women with long hair. So definitely not someone like me, man with bald man is represented in that photo. And so that's what we have learned, that the object we've seen is most likely a black hole, and because it has all the features that a black hole should have. Just to give you an example, the left is observations, the right is the theoretical model. Now you can see how close they are. And you may think, okay, because I know everything about the right one, the theoretical model, I know exactly what is the black hole, its temperature, the plasma, the density, and so on. I know everything about the observations. Well, that's wrong. Once again, remember the example of the women. So what it happens is that, there are many degeneracies. There are many different types of black holes or black hole properties that give equally good images. And this is an example. So the bottom are 3 black holes, which are completely different. They have different properties, and yet they match the images, the observational images, to the same level of precision. So this is good. That means, you know, we have the level of robustness that we wanted. Like it's a woman with a long hair. Here we know it's a black hole, but it's bad because we lose some information. We don't know exactly what is the spin of the black hole because we are not sensitive to that. We need more observations, better observations, in order to break this degeneracy. So this is what we have published in 2019. This is M87. This is a very big black hole, billions of solar mass, 6 billion solar masses. And it's a very large distance from us, 65 million light years, and has a variability of a few days, 1 day at the minimum. And this is what we published instead in 2022. This is our black hole, the black hole in our galaxy, so-called Sagittarius A star. And this is a much smaller, it's about 1,000 times smaller. And this means also that the variability is extremely high. This object changes emissivity in a time scale of a few minutes. Now, I have plotted them, I am showing them exactly how you would see them if you go tonight in the sky, and with a radio-sensitive telescope, you would see them. They are almost the same size. Okay, and this is really a strike of luck because they are very different masses, but the distance is such that at the end of the day, the 2 things compensate. And they look pretty much the same. And we didn't know the mass at the beginning. It was really, again, a strike of luck, because if they were just a bit smaller in mass, we would not be able to see them because they were just too small for our technology. So obviously, you all understand mathematically what the title of this slide is incorrect, but you also understand why it is scientifically correct. If I were a theoretical scientist, physicist 100 years ago, I could do most of my work individually. And I could get even breakthrough results in a group of a couple of students. But this is no longer possible now. There are a number of reasons. Our understanding of the world has increased enormously. Our technology has become extremely sophisticated. And so any progress in science, fundamental progress in science, is much harder. And this means that scientific networking is the key in order to achieve what would be otherwise impossible. The image of a black hole could be done in principle if instead of having 300 scientists, you had 3 scientists, but it would take much more than 300 years to do, okay? Just because of the sheer amount of data that you need to collect. But, you know, it's not just science. Networking also brings out other benefits, which, in my view, are equally, if not more important. You learn tolerance, you learn diversity, respect for the others, friendship, and of course, peace. A very important concept nowadays with what's going on in Ukraine. So any effort that go towards networking will bring scientific advantages, but also all of these sociological advantages. And I should be clear, I think one should definitely support networks, but not only networks, okay? You need also individual science. People like me who work a lot on their own, they also need to be supported. But networks have this ability of promising what is, you know, these breakthrough results. I don't know how I'm doing with the time, but I'm ready for my conclusion. So I try to explain that imaging, taking pictures of supermassive black holes is a very complicated business. You need a lot of expertise going from, you know, radio astronomy to imaging over to doing simulations and interpretations. We have studied in particular accretion on 2 black holes, and we have a pretty decent understanding of what happens, and what happens is closely reproduced by the observation. So maybe we are on the right track there. The EHT has provided the first evidence that supermassive black holes exist, at least in 2 galaxies, and you can extrapolate to the other 100 billion galaxies in the universe. But from my point of view as a theorist, the most important value is that it has transformed a concept, that of the event horizon of a black hole, which I normally teach writing on a blackboard like the ones in this room, into a testable object. And if you remember Galileo's principle, scientific principle, well, that's the way you do science. You have the ability of testing a theoretical prediction with actual experiment. That's what we can now do. As a final remark, if you're interested in gravity and all that comes with gravity, I've written a popular outreach book, which is called The Irresistible Attraction of Gravity. It's been published in English at the beginning of the year, and I encourage you to have a look at this book. Okay, thank you.
I was not living in a cave. I do remember seeing the pictures, so it's been fantastic to hear the story behind the research and to meet one of the team leaders behind the research. That's a lovely example of collaboration across international scales while also maintaining individual research, which is the goal of AccelNet and the cost programs as well. So at this point, we are going to do our roundtable before we take a short break, and I'd like to invite our AccelNet awardees as well as our cost awardees to come up and join us. And we have a series of questions we'd like to put to them. So come on up. And we're going to do a more formal panel for the first hour, and then we'll take a short break, and then we'll have a more informal Q&A where we can address some of the questions that are available online. And Luciano is, of course, going to be part of this panel, and he's available for the Q&A if anybody wants to follow up. I think to start, what we're going to do is go down the line and have people introduce themselves and briefly mention the project they're on, and we'll learn more about the projects as well as their challenges and successes. So I'll start with Raphael.
Hello, everyone. Hi, people online. I'm Raphael Hershey, professor of astrophysics, and I led the cost action called CATEC, which is chemical elements as tracers of the evolution of the cosmos.
Good morning. I'm Hendrik Schatz from Michigan State University. I'm a nuclear scientist, and I'm the PI of the IRENA network, International Research Network for Nuclear Astrophysics.
Laspidou. I'm a professor at the University of Thessaly in Greece, Civil Engineering Department, and I am the chair of the cost action on the water, energy, food nexus, and about the low carbon economy and resource efficiency.
Good morning, everyone. My name is Thanasis Psaltis. I'm a postdoctoral researcher at North Carolina State University and the Triangle University's Nuclear Laboratory. And I'm involved with IRENA project.
Name is Abdullah Konak. I'm a professor of information science and technology at Penn State Berks, and I am associated with the Sustained Food Project funded by the NSF AccelNet.
Penn State in the US, and I'm the lead on the AccelNet project entitled Sustained Food, which is linking US, African, and EU early career researchers and other stakeholders together to address issues in those countries around water, energy, food systems.
Good morning. My name is Dr. Esther Obonyo. I'm an associate professor of engineering design and architectural engineering at Penn State, where I also direct an initiative that's called the Global Building Network in partnership with the United Nations. I'm one of the co-investigators in the Sustained Food project that Michael has just talked about.
Hi, good morning, everyone. My name is Laura Schmidt-Olabisi. I'm a professor at Michigan State University in the Department of Community Sustainability, and I'm also one of the co-PIs on the Sustained Food project that was mentioned.
Okay, so thank you very much for all the introduction. And then it is now the time to start with our questions and get into to see a little bit more about your experience with working with in networking during your research. So the first question is more to Chrissy and Hendrik about your feelings and about what was missing from your funding prevented you from engaging in networking activities that you are doing now.
Okay, thank you. And thank you for giving me the opportunity to talk about this. So yeah, before I forgot to mention, my cost action is called NexusNet, and we are part of the network that was presented, the Sustained Food Network. So first of all, let's talk about the importance of international collaborations, in the sense that we are facing global, the problems nowadays are global. We are dealing a lot with climate change, with the way we use resources, how that affects societies. And it is really, it's an area where there are many silos. People like to work in their own community and in their own environment. And we really need to start dealing with these issues involving everyone. So we have established that collaboration and sitting around the same table and discussing and breaking these silos is really at the core of reaching the objectives. And we are working very much towards the SDGs. If you see the SDGs, there's also a lot of synergies and trade-offs. Even at the SDG level, if you want to achieve all of them, you need to recognize where the synergies are and where the trade-offs are, and to invest in the synergies and have this multiplicative effect that was talked before, that 2 + 2 does not equal 4, but it equals a lot more. And this will only be achieved through collaborations. Now, the international dimension is extremely important, because you will not have, there's no point in us dealing with our issues in Europe, Africa dealing separately, the US or the Americas dealing separately, because we know that in the world that we live in, issues in one continent affect the other. We know that problems, for example, in Africa will, and everybody's talking about migration that might be a result of climate change and of disasters, and this will spill over. And we know that anything that happens in Africa will affect Europe, because we are close. And so it is very, very important that we all collaborate and we see the problems in a very global way. There's no point in Greece, where I come from, dealing with its own little issue, because climate change and greenhouse gas emissions and mitigation and adaptation actions need to be dealt at the global level, at the intergovernmental level, which is what, of course, is happening with the IPCC and at the COPs. So scientifically, it will be ideal to have this type of networking that is happening in, like I said, in the COPs, or where you have all the representation of all the countries speaking about it. So this is, to me, this would be, it really, at this point, where climate change is becoming a crisis, and we see the issues. I mean, Greece was hit very, very hard very recently by extreme floods, and our region, specifically Thessaly, where I'm coming from, it's a war zone. It's a war zone, and this is all will be happening very much, more and more often. So we need to deal with these issues, taking it seriously internationally. Now, why? So I'm very passionate about the collaboration. We are within our network. We're also feeding the IPBES, the Intergovernmental Panel on Biodiversity and Ecosystem Services, which is also very, very important for us. So they are coming to us for input about the nexus, the collaboration of resources. And we are tracking our progress through the SDGs. Okay, so some of the issues is that it is not possible to collaborate. For example, I had a brilliant fellow from Rwanda, and he was very interested in coming to work with me for a short period of time to study, to review the literature and study what is happening in Africa and how that relates on the ecosystem level, how that relates to Europe and the rest of the world. It was impossible, because there was no way to bring someone from Rwanda to Greece, even remotely, that we could do this even remotely. It was impossible because of the guidelines, because there's barriers, and I understand there is, but we need to invest. It's really a drop, a very, very small drop, money-wise, what we would invest. And I think the result would be multiplicative. We will create these seeds of these people that will travel to their countries and then start growing. It is very, very important I see it for our students when they come in contact with, other cultures, other countries. It is really critical that we invest in this. And I think NSF and COST should. Absolutely. We should make calls for such, and involve, if you wish, also Asia. Let's grow this, let's not only limit it to these two, but involve like a global network. That would be so brilliant, and it will open up so many opportunities for our students. They deserve it. It's the new generation that they deserve to see this global dimension. That's it for me.
Thank you, Chrissy. That was super inspirational and very ambitious. So, Hendrik, how would you see it from the other side of the ocean? From this side of the ocean in this?
Our network deals with very different type of questions, taking it kind of back to the black holes and basic science. So we're interested in basically understanding the origin and evolution of the chemical elements in the universe, sort of over the history of the universe. And even though it's a completely different topic, we deal sort of with the same challenges that things are siloed. We need to bring together a lot of different communities in science, nuclear physicists, astronomers, gravitational wave physicists, geochemists, and these communities don't talk with each other, different funding agencies. And so it's kind of the same challenge. And we've had previous funding actually through the NSF Physics Frontier Center program. It's a very nice program to build kind of a national network that brings together these communities and different capabilities, different accelerators, different observatories at the national level. And also, I would say, a new approach to science, a new, at least for our field, a new approach where you really collaborate on a large scale with many institutions and many sort of sub-collaborations. You come together into kind of a coherent strategy and approach to these big scientific questions. But then the AccelNet program was really, I would say, a game changer in allowing us to sort of take that approach to the international level. And that's very important for us. There are many accelerators around the world that are essential to do the experiments that we need to do in nuclear physics. There are many observatories that we don't have access to in the US that are needed to answer those questions. And so that was really, I would say, a game changer, and allowed us, for example, to connect with the Cost Action Network that had similar goals that Rafael Hirschi is leading, and he'll say more about that, and 4 other networks in Europe and Japan initially. And I would say I was kind of surprised actually how well that works, and sometimes feel like you run to open doors. Since we started 4 years ago, 4 new networks have actually joined in Canada, more in Europe, and also a network in Latin America most recently. And I think that shows that there's a huge untapped potential. There's a lot of scientists and scientific communities that would love to collaborate internationally. But you need a framework to make that happen, and a little bit of support. Otherwise, it just doesn't happen by itself. And so that was very interesting to see, and it greatly accelerates the science. I mean, that's why we really do that in the end. But it also addresses inequalities and access barriers. We get hopefully now users, for example, at my local facility at Michigan State University. We have an accelerator, and I hope we'll get new users from Latin America to do nuclear astrophysics experiments. And the facility is open. Anybody in the world can put in a proposal, but it just doesn't happen, right? There are barriers, and you need to address those barriers sort of deliberately.
Thank you. Those were both exciting for Kata and I, certainly, on the funding side of things, progress that you've made in your applied and basic science fields. It's very exciting to hear that. The next question is actually probably focusing more on challenges. So Esther, this one's directed at you initially, and then others can answer if they wish. What is the biggest challenge you have faced in international network building?
I'll start with giving a little bit of credit to my students. I teach an African futures class, and I told them I was going to be here today. So we did some validation. I had my list and they had their list. And interestingly, they were very similar. So as we said earlier, we are all, the four of us are part of the AccelNet that's focusing on food security. And Mike already shared some background information. So I'll just build on top of that and say that the model that we're using is based on looking at the water, energy, food nexus, the three systems and the interconnections, interdependencies, synergies, and trade-offs. And I'll actually start by telling a story that explains the challenge that we're dealing with, how the challenge plays out from an international collaboration perspective. In 2018, the governor of Edo State in Nigeria visited Penn State. This was a reverse visit. We had visited Nigeria, then he came to Penn State. And there was collaboration. We set up a mechanism through which he was going to do some pilot studies in Nigeria. Then the next time we saw him, we were like, what happened? And he's like, floods. Everything got destroyed. And that's just to explain that the issue that we're dealing with is really a complex, wicked problem. And we had no way of knowing that that was going to be the biggest problem, for moving forward with a nice pilot project that had a lot of support. So we see having these international network-to-network connections providing us a basis to inform each other. Yeah, but then the challenge is there'll always be some of these unexpected things, wildcards that we cannot really plan for, and it can be very discouraging when that happens. Then moving on, the other thing that we've also experienced and I've experienced is war, and our projects being impacted by war, conflicts, and also disasters. Like we were talking about, we had started planning an activity, collaborative learning school in Mali, and that's not going to be possible. It looks like it's not going to be possible because of an earthquake. And so we have to go back to the drawing. Morocco. Mali is because of conflict. Sorry, both of them were being considered. Mali was because of conflict, Morocco because of an earthquake. So that's, it's just there that as you make the plans, you have to bear in mind that there could be some disruption that you had no way of really accounting for. We've also had experiences which are linked to cultural differences. In the recent activity that we had as part of the AccelNet in Uganda, I was observing quietly how, because we're doing community engaged research, we are following all the methodologies that have been recommended by all the scientists who do community engaged research, funded by NSF and other agencies. And we engage the local community through the local university. They brought the community leaders, and we plan our day. We are going to leave at 7 or at 8, and we have a full day of activities. And then we realize once we got there that because we're going into the community, they also have their requests. They want to engage with the political leaders. And it comes with a lot of benefits, but it also comes with a lot of scheduling challenges because they have other responsibilities and they can get pulled out at any time and we can't leave. We're in a limbo, we're waiting. So the time, we realize that when you plan for 2 weeks, it's based on the assumption that you'll have control of the day schedule from 8 o'clock to 5, when on the ground, you might be waiting in a limbo for maybe 4, 5, 6 hours. And once you started waiting, you cannot leave. You cannot tell people, okay, we come back tomorrow because the political leader says, wait. And we had to wait. And then there are other things that because of the history of colonization in African countries, our partnership is focusing on US-African partnerships. There's the local dialects. And there's also, if we move to a country that speaks French, for example, some of us do not speak French. We're going to be relying on translators. In the recent experience, it's an English-speaking country, but then we realized that at some point, the translators were synthesizing and interpreting. They were not translating. And something can easily get overlooked. Something important was getting overlooked. So fortunately, one of the locals in one of those instances spoke up and said, hey, stop doing that. You're not giving them the accurate data that is valuable for this research. We also worry about long-term sustainability. We are dealing with a complex, wicked problem linked to food security, but with also acknowledging the interdependency with water and energy security. And 1 year, 2 years, 3 years, 5 years is not enough to resolve these issues. So when we are living and the problem hasn't been resolved, we do not want to lie. We do not have unlimited funding. But then when we're asked, like the farmer is saying, here's a problem that still hasn't been resolved. What is the plan? We don't really have any easy answers to that. There's the problem, some minor problems are about like metrics. some of those countries use SI standard units, the SI units, they talk in meters, they talk we talk in feet and inches. And it sounds like a small thing, except when you start doing things like ordering materials and something didn't get translated or converted properly, it will cost a little bit longer. And I'll just stop there. So there are these things which end up taking longer, or they end up costing a lot more than we thought that it was going to cost because of some of those issues that we have raised. Thank you.
I'll just add a little bit to these challenges, because what's interesting is the two projects or themes selected couldn't be more different, right? We've got something very theoretical and a specific objective you're after. And ours is water, energy, food nexus, which couldn't be more diverse. And so, and the way I think about it, and I think Luciana mentioned the observational problem or challenge, you know, to actually observe the black holes. And we observing people, right? We observing communities and their activities and their technologies they use to improve their livelihoods, no matter where. And everywhere is different, right? And you sort of alluded to the black hole challenge in terms of differences, and we have that same thing. So no one place is the same. So to use analogies from one community or another is difficult. And so I think that dealing with the people is really important. We have that sort of extra dimension of a sticky problem. Anyone else want to comment?
Yeah, so the biggest challenge is for us knowledge transfer and science policy interface. You know, people talk a lot about that, but it is so real. We do all these papers and we research and you know, we develop tools. You know, I come from the engineering background. Nowadays, it's all kinds of digital twins and fancy satellite pictures and all that stuff. What is the value? What is the value if you don't transfer it to the communities, if you don't transfer it on the ground? So it is really critical. And for us, I understand that this is our biggest challenge, because as Mike said, we are dealing with people and societies. I will just bring an example in another project that we are running. We had Professor Sachs in the advisory board, and he heard all the progress, and you know, we're doing so many technological things, and you know, really the whole range of bells and whistles in that. He's like, yeah, okay, I see that, but what about the political process? And there I understood that this is where things are changing. If you are just developing things and you don't understand the political process, you don't understand how these things, where the barriers are, how you make science into reality, then you will just stay in your academic world. You will be happy to publish, you will be promoted, but you will not bring about transformative change. And if we want to bring about transformative change, we need to focus on understanding the political process and understanding the lobbying, understanding the power structures, understanding the communities, and bringing change. And of course, a German politician with a Greek politician and an African politician and the US politician are totally different animals. And we need to understand all of them. And we need to find a way to approach all of them at the global level, because the crises we're facing are global. So science policy interface will only happen if we deal this at a really collaborative and international level.
I could mention one challenge that we ran into. So one of our goals is to create foster development of early career researchers, professional development, and also create welcoming and inclusive environment at the international level. So that's a great goal in itself, of course, but it's also absolutely essential if you want to have this sort of true international coordination and collaboration. And it was kind of interesting to see that I mean, coming from the US, these things are not prioritized the same way in every country. So that's something we ran into. Things we have implemented in the US don't necessarily work the same way in other countries. Even the understanding of what a welcoming and inclusive environment in science is differs from country to country, yet you have to somehow come to the development of such a inclusive space, because I mean, your students will go to meetings in other countries, and if you want to have this truly international space, it's essential to overcome these. But in a way, running into these challenges, I think, tells you that you're doing something in the right direction, and we're making good progress, I think, but it's not always easy. And a small incident can have a big impact on how the network can operate.
Thank you very much for sharing all these insights, and from the daily to the daily life of yours to a more theoretical overview. And thank you, Henry, for a little bit finishing on a more positive note, that these challenges are not only there to hinder, but also to overcome. So the next question is to Abdullah, maybe to take the next step out of the challenges, how then the international collaboration can advance the science that otherwise would not have happened, and what are the results that have been achieved thanks to that.
Thank you very much. Thank you very much for organizing this panel and being here today. I mean, first of all, let me tell you, my research is basically optimization, modeling, and solving problems using mathematical techniques, and it's a little bit theoretical. So when I start engaging with these groups and then international collaboration, the first thing that I felt is, oh, okay, now I can actually use those models and algorithms that I develop and the skill set that I have while developing them to apply some real life problems, and then it can really make an impact. So that was the feeling that I have. I still have that feeling. So I feel happy about that, you know, being able to apply the skills that I have to real life problems. And I think I'm going to focus on 4 things, and I will start from the last one, which is the dissemination of your research results. I think international collaborations really increase your visibility as a researcher and increase the impact, but also how you make that impact and the dissemination of your results. And I look at my publications, and I don't know somebody studied this or not, but the publications that I have, international collaborations, have higher citations. Maybe somebody has to study on that. And you cannot go to every conference. You know, you cannot be in so many places at the same time. And with the international collaboration right now, for example, we have another NSF Belmont project. Or if you cannot go to a conference, you know, one of our team members can go there and present and get deep and quality feedback quickly. And by leveraging those collaborations, we were able to, for example, to present on different countries in different places and able to collect feedback from different groups. Like I can give you an example. At the beginning of this summer, I come up like a way of integrating like multiple indicators to design a drought resilience index. Okay, so it's kind of like a mathematical way of doing that. And then the whole summer, I needed to have some data, but our Brazilian partners just right away sent the data. And then I run some results and then presented in a US conference, and I got some feedback. Like most of the feedback was like kind of technical, or you have to do this way, you have to do this way. And then our Brazilian partners, they got excited about this new technique, and they presented in a conference in Brazil. And then I asked them, oh, people like that? They said, no, they didn't like it. They said there was no scientific basis for this. But it starts make me thinking, okay, what is the scientific basis for this, that I'm using this mathematical technique? And I was able to get that feedback in 3 months quickly, and which is impossible to do for me. And Another thing that I want, yeah, this is like, I think, very important. When you present at different communities, different places, you can get this deep quality feedback that you cannot get presenting only to your community or your country. And I think the second point that I want to mention is accessing the data. And more importantly, I think Luciana mentioned about this interpretation of the data. I mean, if you do a research on climate change, you know, how can you do a climate change research just only for US? I mean, that's impossible, isn't it? So you have to have the data to validate and verify your results in different countries, in different communities. And accessing that data is not easy. So you need people in those countries that can help you to collect the data. And more importantly, you know, when you analyze that data, you have your findings to make sense of that findings, interpretation of that findings, because that could be really, really different. Depends on the realities of that country, and you know, the context is very important to analyze your finding. I think this is actually, you know, I see that by international collaboration, that's increasing in my research. And knowledge transfer, I think you mentioned about that. You know, I learn a lot from my international collaborators. I think international collaborators learn from me during those collaboration, and it will be impossible to do. And so I'm in an institution mainly focusing on undergraduate research, undergraduate teaching. So I don't have access to PhD students. I don't have access to master level students even. So the question is, you know, how can I do that? I think international collaborations is a way that I achieved that during my career. I worked with, you know, researchers from China, Taiwan, Israel, and different countries, and I was able to, you know, work with their PhD students, and I think that increased my research productivity. And finally, you know, you have access to different expertise that you cannot have in your institution. I mean, right now, we have like a very multidisciplinary researchers, and then everybody brings different perspectives to the problems that we are trying to solve. The process is slow. Okay, the process is slow, but our Belmont project, what I realized that after 2 years of slow process, now when we come to the dissemination, things actually pick up. It becomes like faster because, you know, different groups can, you know, produce different papers, conference presentations, and so forth. So I really enjoyed that experience.
In the interest of time, can we just move on and then we can revisit all of these questions during the Q&A, because I'm sure all of you have a lot more to say. But Abdullah, you're actually correct. There have been studies done showing that international collaborations tend to be more highly cited. So yeah, so your own personal observation holds true. Yeah, but it's part of a larger one. So the next question is, what has been your most creative or rewarding network activity that led to a breakthrough for your team science effort? So this is building on the previous question. I believe, Laura, you've identified this as a question you'd like to address.
Sure. Okay. So a lot of the kind of overall points I was going to make, my colleagues have already chimed in on. I agree with everything they've said previously. So I'll just back up a little bit and, you know, emphasize that we're focused on the food, energy, water nexus in Africa. And as you know, there were some comments earlier about why Africa is important. I think it's going to be the story of the next 50 years, just like Asia was the story of the past 50 years. Just a couple little tidbits for you. Of the people added to the planet between now and 2100, half of them will be African. It's expected to be one of the continents most hardest hit by climate change. And so there's huge global security implications, huge ecological implications, migration, global trade, as people have mentioned. So it's a really important area to be working in. And we have to be honest that a lot of the research that has taken place in Africa to date has been kind of extractive, right? It's been researchers from the global north coming in, making studies, you know, getting publications, getting promotions, getting grants to do that. but maybe not necessarily seeing benefits to local communities, local researchers, and the countries themselves. And that science has often been used to make policy that directly impacts the lives and livelihoods of people on the ground. So there's really an equity and kind of ethical argument that we need to be networking with African scientists and African communities much more tightly. And I am, appreciative that, capacity building is such a big part of at least what NSF is trying to do with networking. So for example, one of our colleagues that's with us in the AccelNet was funded by the PEER program, which is a joint program of NSF and USAID to work with me a few years ago. And that's how we started to work together and kind of integrate into this current network. So the way that we're doing this kind of practically on the ground is through these collaborative learning schools. We just had the first one in Uganda, as Esther mentioned, in July. And so our goal there was really to work very closely with local institutions. We worked with Makerere University, and again, a relationship there that was funded through prior networking funds, in this case, not through NSF, but through Michigan State University's Alliance for African Partnership, which was how we built that relationship that allowed us to go in and truly have close ties with local researchers and local communities through the extension program of Makerere. So again, I think if we're trying to do research that is non-extractive, we have to put time and energy and money into that relationship building. And it just is better science as well, because, the researchers that are local in these African countries, they have the deep knowledge of what's going on there. They have been working there for years. We kind of come in and we see things on the surface, but they know the communities, they know the situation, they know the ecology. And we really need those collaborations to be true partnerships in order to both advance the science and advance the policy. And so this collaborative learning school was an attempt to kind of link the participants to both the practical problems that were happening on the ground, and then also the policy aspect, and that we involved local decision makers and local stakeholders. And it was really a rewarding thing. It was our first one. We're still processing it. We're still developing recommendations and follow up from it, as Esther mentioned. So we'll let you know how that works out. But we got rave reviews from both the students and the community partners that we worked with on the ground there. So that's something that I would just emphasize, is that, as we're moving into, a new era of science, we really need to be working in true partnership form, I think, and being cognizant of the fact that our colleagues in African institutions have challenge, some of them were mentioned, have challenges that are different from the ones that we face. They're very poorly resourced. They usually have very little funds for research or travel or attending conferences. They often have a huge teaching burden because Africa is a continent that's vastly underserved in higher education. So they have enormous numbers of students they're teaching and advising. So I think if we want to work in a partnership form, we have to be cognizant of those kind of imbalances of power and access. And networking funds can help overcome some of that.
Thank you very much for that insight, and maybe we move to the next question, and at the end we make a tour around if anyone has a point to add to any of the questions. And the next question is also picking up on what you explained, maybe from another angle, because it's about young researchers. And the question is addressed first to Tennessee, and then maybe Luciano, you would like to comment on that further on, because the question is about in your view how international networking impacted your career as a young researcher, and how you feel to be involved.
Thank you, Cara. So my main message would be that international research networks such as IRENA and the Cost Action actually provide invaluable experience and invaluable assets for young researchers like me to advance their careers via multiple ways, such as interdisciplinary training, which is very important for our field in nuclear astrophysics. Also by lots of networking opportunities between the different members of the networks. And of course, the most important thing is that it fosters a spirit of collaborative research. So we're moving from the competitive science into a more collaborative spirit, which is what also Luciano mentioned in his keynote. I can give you a couple of examples from my own experience. I received my PhD in 2020, right in the middle of a pandemic, from McMaster University in Canada. And then I moved to Europe, in Germany, in Technical University of Darmstadt, actually very close to Luciano. And as you can remember, during 2020, 2021, international travel was very limited. I couldn't even go back to my home country, which was only 2 hours flight away. I was still stuck in Germany. And something which is really important for early career researchers is to expand their network of collaborators. However, due to the fact that I was a member of IRENA, I had lots of opportunities. One example is that with other early career researchers, we're organizing an online seminar series. So it's a 2-week bi-weekly program in which we invite one expert from our field to give a talk and discuss with the community, which was really important because on the one hand, I had the opportunity to meet senior researchers. And on the other hand, I was checking all the latest advancements of the field. So that was really important. The other interesting aspect of IRENA and all the networks like IRENA and Cost Action is that they also give lots of opportunities for researchers, young researchers, to take initiatives and organize their own workshops or conferences. There are summer schools that are organized by IRENA. Right in the pandemic in 2021, I organized a virtual workshop about a specific topic that I was interested in, and that brought many experts from the field from all around the world. It was virtually organized, and IRENA actually supported us. And the best part was that after the conference, we also got an invitation to write a review article about the topic of the conference, which I'm actually right now working. So I don't know if Luciano would like to chime in for the researchers.
A great, I can stay here. Okay. So I think you've done an excellent analysis and summary of all the advantages of being an ECR in a collaboration. That maybe one additional remark I would do is that an ECR in a network also learns to be a good scientist, something that you don't normally do when you are in a much smaller group. But by that, I mean, not necessarily being, smarter, but being able to cooperate with others, accepting that people may have views which are not the same as yours, and interacting with them in a collegial manner, and the whole idea of having, for instance, rules of conduct, respecting your colleague. That's all something that you learn if you are in a network, because these rules are much more clear, much more easily spelled than if you are just an ECR with a professor in a university. So I think that's certainly an important advantage. You become a more modern scientist.
Thank you. That's really actually very useful for me to hear, because one of the two main agendas of the AccelNet program is workforce development of, as young as you can get to early career postdoc, and also in team science at a global scale. So I think it's really, that's feedback that's really useful, that, we're emphasizing the right thing, which is great. The final question, and then we'll take our break, and then we can revisit any and all of these questions, because I'm sure you all have lots of things to add. The final question is, how do you foresee to continue working with your network peers following the funded project ending? And this is critical on my side of things, and potentially Kata's as well, because our programs don't allow for renewals. We don't fund the centers, we fund the networking activities, and that just can't go on and on and on. So we are very, very curious to hear what your thoughts are on this. And I'm going to turn to Raphael first. You haven't said anything yet, and then we'll go to Michael after.
Thank you very much. Well, networking is a very crucial stepping stone to build teams, collaboration. So when we create a network, we share expertise, often training. Most of both schemes, the COS and NSF, have a strong emphasis on training and visiting each other. And in the case of the KTEC cost action, we managed to go to the next level in 2 ways. The first one was joining NSF Network of Networks, so with Henrik as part of IRENA. So taking the international cooperation from European scale to global scale. And the other way is starting to share resources. So we then, as a cost team, we then applied and we had a much stronger proposal to apply for another Horizon scheme. But now in this case, not just sharing network and visiting each other, but also sharing facilities. So in nuclear astrophysics, as Henrik explained, you need experimental nuclear physics facilities, you need telescopes, and you also need computing resources. Because we had built this network of experts in these different disciplines, we could then make a strong case and design the sharing of those facilities in a coordinated manner. So not just applying for some scientists applying for telescope time. Now we are able to apply for a coordinated telescope time, computing time, and experimental facilities to really make swift progress in nuclear astrophysics.
We've heard today is these take time, but we actually started our informal Water Energy Food Nexus in Africa network before we got funded through NSF and AccelNet. So we had this network to networks already going, which I think, and AccelNet has helped us accelerate it, so to speak. And we decided to focus just on US Africa, right? The NSF are interested in the next generation of US scientists, but we've seen how important Africa is. And we could have decided to go global, right, in our proposal, but we felt like, let's start with a region, and then maybe, I think, we're only in our first year, so after 5 years, and even before, I think, for example, if we do our next collaborative learning school in the US, maybe we can bring in experts or early career researchers from Latin America or other countries to join us as well, so we can start to build beyond Africa, so to speak. And so I think the next step after is to kind of work from a global perspective on bringing these researchers together. I'll stop there, but I have a lot to say after the break.
Well, there's still plenty of food, so please feel free to eat as much as you can. And those online, we'll start to address some of your questions in the Q&A afterwards to any of our panelists, including our keynote Luciano or Kata and I about our funding program. So maybe 10, 15 minutes, and then we'll reconvene. Okay, welcome back, everyone. We'd like to just open up to questions. Maybe first we'll allow our panelists to chime in on questions that they wish they could have chimed in. I think that's going to be Michael definitely chomping at the bit a little bit, but the others also, if there's a question that you heard that you'd like to contribute to, we would like to open it up, and then we can open it up to the audience as well. Anybody want to ask?
Yeah. Okay, maybe you can monitor that.
She says fast to say what you want.
No, I wanted to say a couple of things on how we can. One of the questions was how is this collaboration advance research, and I think it's not only research; it's bringing international experiences back into the university through teaching and extension. So I don't know how many of you are as old as me, but like 25, 26 years ago, when I started off, I was doing work in Pennsylvania and internationally. And first of all, there was very few faculty who were doing international work. They felt until they got tenure or something like that. And the other thing I noticed when I started was there was very little interdisciplinary work. And now both of those have changed. And I think people are more attuned to realizing the importance of international collaboration, not just the linkages we heard this morning about research benefits, but
it's going to be difficult to repeat. I just want to mention our project has this early career researchers group that they organize themselves. Okay, they show leadership in the activities. They take active role. I mean, we don't really interfere with their agenda, you know, what they're supposed to do. And I think it's a great experience for them to show leadership in research. And, you know, they make a significant contribution to our project. And it has been only 1 year.
Yeah. And I'll just say this group, and I encourage anyone who's in early career researcher to get involved. And just imagine if you're African in a, you know, us Americans have much more opportunity to engage at a larger university, but a lot of our African early career researchers are pretty isolated. So bringing this group together for them has been eye-opening, and it's really good for them to be in the leadership of having these webinars and other activities, collaborathons, and so on.
Unless you speak French.
I will be brief. My name is Sergio Rossi. I'm a chair of a construction called Marine Animal Forest of the World, about the seascape of the oceans, coral reefs, on sponge grounds, so on and so on, and the importance of these cost actions and this networking. But I want to just put here a much more, complex thing in our minds. We know that we are in a very complicated moment that we build up during this last decades and more than 150 years. I have to be honest with you. I'm also expert in historical ecology, and I know what I'm talking about. And what happens here? We are growing up a new Babel Tower to resolve the huge complex problems that we have, not only climate change, biodiversity loss, but also the lack of renewable and non-renewable resources, petroleum, aluminium, cobalt, and so on and so on, in a society that during the last 150 years thought or was intended to be much more egoistic, egocentric, and individualistic. And guys, that's the problem, because we have to have transparency, which is not easy, confidence and trust to the other people, which is not easy. And I would say friendship, but this is very difficult sometimes. But at least having the you to you, this is in Spanish, tú a tú, that is just the confidence that the other people is not below you or up to you. And due to the geopolitical situation that is fastly changing with the fastly changing world, this is becoming more and more difficult because we are making exactly the opposite thing. We are isolating the countries. We are isolating the solutions and say, okay, I face the problem, but I don't want to know anything about the others. So I put here this kind of just thought that I think is very important to just take into account and to understand. Thank you.
I guess a little bit of science diplomacy. So maybe science could bring people together and make friendships and fight racism and fight all these issues. Yeah, I agree. Very important. And going across cultures, I think that is also very important. Understanding the differences. And you only do this if you actually go there, as Esther was saying, with the different peculiarities of each culture. It is so hard to predict and to understand how people live on their everyday lives. So for our students, this would be a monumental opportunity, to travel either to Africa or to the US and get exposed. I mean, anytime they've done something similar, they remember it for years and they mature so rapidly after this. So, and this gives them the material to grow and to become leaders where they are. So we should really, push for such initiatives more and more.
Yeah, I think you made such an excellent point. And I think it's on all of us to reflect a little bit about how our modes of scientific training and our institutions have fed into this problem rather than taken away from it. And, there's a great literature on the science of team science and also the science of collaborative science that points out that some of the virtues needed to do this important work, as you point out, are almost exactly opposite sometimes of the ways we train young scientists. So for example, humility, right? Recognizing that you don't know everything. Maybe your colleagues have solutions that you don't have. Is that really the way we train students in our universities to be humble, right? Or is that what we're modeling? Empathy, understanding where someone else is coming from. So I think that you know, we need to put it on ourselves too, to think about how are we training researchers and scientists to collaborate in these teams in a way that, as you say, is so needed for the 21st century, and to bridge these gaps that we have, and how can we make our own institutions better, you know, kind of looking at that.
Build on that. So the AccelNet program offers all of our teams training in team science. That's what you get in your first year. As soon as your award starts, we have a external set of contractors that give you one-on-one sessions with your entire group. And I'd be curious from the AccelNet awarded teams, how you feel that went. Do you feel that was beneficial? Do you feel that helped address some of those gaps, those of you that participated?
Yeah, I can talk about this in terms of the project evaluation, because we get some training, for example, how to evaluate the network and the relationships grow. And we are going to implement some of the learning that we have on those programs. I think you guys attended the network analytics workshop. So like we create, I mean, we change our original evaluation procedures a little bit. So we're going to implement some of the learning that we have in the training to evaluate the success of our project. So I think it has been beneficial in that sense.
Yeah, that's the network analysis where we understanding the linkages between people working in the same area. So that was an excellent training. But also we had a session with other AccelNet awardees who are working in Africa, which was really good to see what they are doing, and likewise try and link up more and cut across our project. So that was really good. And I encourage, and maybe we could do that the same with some of the other cost action workshops to find synergies through these not training sessions, but discussion of team science. Yeah, I think just the experiences of us getting together to learn how do we get the challenges with early career researchers. I think, we're all doing this network to networking, building networks, which is really challenged, because how do you keep the momentum, right? How you can create a workshop, and how do you keep that network engaged? What are the incentives for them? What's in it for them to stay engaged, so you expand this network? And I think that's a real challenge that we all need to work on.
Yes, I was going to add that we did the training before we had our first international network-to-network activities, and it was very valuable. And I think maybe there's also an opportunity now that we've had that and we've come back, there's an opportunity to close the loop on things, like what was applicable, like for us, like how can we close the loop on that? So that's more like a request than anything else. Let's bring in the in-field experiences into the team science.
Yeah, I could add, I mean, I find those AccelNet meetings very, very beneficial, in the sense that, as you said, the challenge is, I mean, it's basically, I see it as a social engineering problem, how to run an international collaborative network. Everybody wants to collaborate, they see the value, but how you make it happen? Everybody's busy. You need to create incentives. You may have a good idea and something starts working. How do you keep the momentum, as you said? So that's the challenge. And there's only so much you can do. I mean, you're not an employer who directs the employees, right? You can't tell anybody what they should do. So you have to create initiatives, incentives, and these meetings, I think, are incredibly valuable in that you hear what the other networks are doing, and you can exchange, what best practices and what has worked and what hasn't worked. But I think fundamentally, what has been brought up, that you have to learn how to do team science, that I see more like a cultural thing that you have to really develop in your collaboration, and it's not one training session or one meeting where you suddenly become a great team player. It's something that you have to sort of step by step implement and get to over time. And these cultural changes are also very challenging to foster.
Great. I'll also share a story, very anonymized, from one of our other teams who encountered this challenge within their first year. meeting with one of their partners and everything fell apart. And they've been going through 6 months of damage repair, learning how to learn again, learning how to learn from each other, learning how to cooperate and coordinate. So it is essential when you're working cross-culturally to try to understand what those differences might be in advance and be respectful of partners. That's, I think, from what I see from my own scientific background in biological anthropology, that's the biggest challenge that faces anybody who doesn't have any training in social sciences and is trying to go out into the world and coordinate with others without understanding that the frontline problem you have to address before you get to the science, because too often science tries to cut through, but that's not a common language because we all engage in science differently and prioritize things differently. So all of your experiences are reflecting that tremendous potential for learning, and which is why we think it's so great to involve early career researchers in these projects. And it sounds like, Thanasis is our sole representative here in the very early side of things, has echoed the opportunities he's received, which is wonderful. Do you have any additional questions, Kata, or is there any other comments?
I just thought of keeping of this momentum for a while, because actually the cost actions, this is what they are doing to cut through the science and to mobilize the research community, creating the network, while someone already has their full-time research and any other research activity and another responsibility. So if you, any from the present cost action chairs or previous chairs would like to share how actually you can make it that people from your networks, which are quite large, with more than 200 people sometimes, to that actually this is a network that is mobilized and work efficiently, while you can still answer the other responsibilities of your life, maintain.
Very good point. Very good point. So yeah, I don't know if everybody understands that in cost action there is no, the work is not paid, so you have no personnel cost. So everything we do it out of our enthusiasm. And of course, enthusiasm has a limit, eventually it runs out. My network now, it's what, a year and a half, and we are over, I don't know, 250, 260, I don't know. They keep joining every day. Eventually I'll tell them, enough, don't join anymore, because it is really massive. And I am paying now, I've put a third person on the team that I'm funding from other sources, because there is a lot of logistics. So how do you motivate these people? Only with, I will say, with enthusiasm. So we try to pick enthusiastic people that are very passionate about what we do. Usually publications, joint publications are a very big motivation. People that, once you say publication, they will join in. So this is and it's a good chance to gather input from all these different people and backgrounds, and create something really unique that you would not be able to do otherwise. And then people need to have a vision. So what I do in my network, I try to create the vision. For example, we have set like we will have our final event in the parliament. This is our goal. I don't know if that we will reach it, but this is what. So we set an ambitious goal, and so we're all going to start contacting our MEPs from our countries, create this body of people. So when you inspire people and when you give them a goal that is really ambitious and different from what they do every day, they will join. And then, of course, the travel, the US connection and the African connection was a very big carrot, for them to get involved and to meet. So it's all this opening their horizons. That is very, very unique. And people will join for that. But I think, I was thinking that it would make sense to have some, maybe some funding for personnel. I don't know if I should say that, but maybe there should be a little budget for that. I think in NSF there is. Yeah, little. Anyways, I mean, a lot of people complain because it is massive work. But I am in a good position that I have a lot of other projects to supplement. So I don't think it would be easy for someone that doesn't have other funding. But for me, I mean, I try to connect it with all the activity that is already happening, and it really creates the mass of people from all over, and gives initiative to the other. So it works synergistically with all the other projects that I have. So at the end, it is a very positive experience. But you need someone that is really, passionate and inspired, and this is what we should all do. Yeah.
Yeah, I think the two things I would add is we have to not be scared of failing. And so normally not every initiative will work. So trying more initiatives than what we think we can achieve, because it's hard to predict. But I would also echo the ambition that as a network, we can achieve goals. Like, for example, this EHT project. No single institution, no single scientist can achieve those goals. And I think if we have a clear vision, an ambitious vision, then people buy in that vision. They say, okay, I know I can't do this on my own. I know I have to team up to achieve that goal. And having those ambitious goals really brings people together, because they as I said, as we heard today, you just know you can't do it on your own. Climate change, we can't solve it on our own. So we really have to team up. So really going with these ambitious objectives is quite important. And also maybe split it into separate initiatives, maybe separate ones, so that if one fails, then still other initiatives can succeed. As long as some of them succeed, then the group wins.
Thank you very much for sharing your enthusiasm, and I wish that it would be kept alive for a very long time, and also it would be shared among maybe newcomers, and because I think enthusiasm is one that makes, and the vision that makes cost going along.
Okay, so.
Okay.
When I said, after our project, maybe developing a global network, but I think already we're seeing more concentrated regional networks, which I think is better. For example, there's a Southern Africa community of practice that's already been established, that we helped establish already. So I think, bringing it down to the local level is just as important as well. And I forgot what else I was going to say. But yeah, we'll come back to it.
Another point I wanted to raise is lines of communications. So, for example, in our network, we see that, for example, you could have one American scientist trying to work with one scientist from Asia or Europe, but it's generally quite hard. And having those network of networks really adds points of contacts along the way, facilitates the dissemination. We talked about dissemination. You can have a collaborator who can explain the results obtained by the network. But also, we talked about the junior researchers, that they have access to more expertise through the network. And really, like, for example, when we say, well, we look for junior scientists in a different continent, and Henrik just can't do that because he doesn't know directly people. But then he can contact me or the other network, and the other networks can find more easily and disseminate information, opportunities in a much more efficient way. So it's really the international cooperation is also having these lines of communication. If we think we want to change politics in different countries, well, you need somebody from that country to talk to a politician, because you can't be like, I'm a Swiss, I can't go to like South America and tell them what to do, right? So, and that's why all these networks are so important, to have local people to relay information, disseminate, provide opportunities to people in those countries.
So another thing we try to do is always wonder what will be our legacy when this is over, when we finish the project. What do we leave behind? So I think this is also important for the network to envision what is needed and what will be left behind. So from our point of view, we're putting together a massive database of all the Nexus projects that have been funded in Europe and beyond. We will definitely expand this. And our ambition would be that any project that is being funded afterwards on the Nexus, they will have so this database will exist and it will be operational, and they will be able to log in their case study, and then it will be visual. So you will be able to go in and see who connects with whom, and who are the stakeholders, and what are the elements, the Nexus elements that are given more emphasis. So this is also something that people can be inspired that after this is done, we will have this that will be serving the community, for the years to come, and they like to be part of this, so this is another inspiration.
So I just want to maybe raise a bit of a controversial issue here, and hope that to have the year of the NSF, but also of cost action. I think something we are experiencing over the last few years, which we haven't over our careers, is that barriers have been set up among scientists. We've just seen all of a sudden, for instance, our interaction with Russian colleagues has been completely wiped out in a matter of a few hours. And we see that tensions are raising between even just visiting countries which were otherwise, transparent when allowing in scientists. I've seen how complicated it is sometimes for a Chinese to enter Japan or vice versa, and these people write papers all the time. I think we should try and clarify that this is not acceptable, that science should not have this barrier, that people can have wars and so on, but that science is necessary in order to avoid these wars. And that as soon as we create barriers between, scientists, then inevitably we just feed in this logic of separations and conflict. So I think this is something maybe we can leave as our legacy, that these things should not happen.
I would like to comment what Chrissy just discussed and open the issue of legacy of our cost projects. And maybe I can just give you some example of the project that I was co-coordinating. And this was related to dust issue, mineral dust, transport impacts, and so on. And there was a question, this project ended up 2 years ago, but a number of people just ask how all these results should be available more to the community. We found a way to do it, and with the administration from cost, we agreed that all the workshop results, tables, data collected, results, and so on, should be inherited by UN organization, World Meteorological Organization. Now they undertook the website. Most of the cost website is now alive, and of course there is always a reference to cost action group, but part of the group also comes from the United Nations within the cost. So it was a good way to somehow continue visibility of the EDIT project.
No, it's related to how we're working with the NexusNet cost action, because a concrete example, they had a training with about 25 students in Lisbon in May, and we were invited, and it was a really excellent opportunity for us to see how they recruited their early career researchers. They made sure that their recruitment, the students were already working on a Nexus project, they had to present it. And it was a bit late for us for our first one in Uganda, where I would argue, and I think my colleagues would agree, we could have done a much better preparation for the students. So that's an example of learning from being in part of this network.
Hello. Well, for starters, I'm absolutely happy to be here because there's discussion on space as well as food. So it's like my heart and mind are both over here. I work in the agriculture space, and space was my passion since birth. So very happy to be here. I have two questions and one sort of a suggestion. Well, yeah. So my name is Sarang. I am the founder of a startup that works on sensing and data platforms for agriculture. And well, I'm originally from India, so a lot of our operations are in India, and I'm from the private sector. So my question is there any interest of this initiative in Asia, or rather India, and for private sector engagement? Maybe not exactly through this program. I'm sure NSF and COST both have their own ways of engaging with private sector, but I would love to know more, even offline, perhaps, about that. My second question is particularly for COST. I know of the Horizon program, and we've tried to participate in that, and I know it's like a funding mechanism. Are you different from that? Are you complementary to it? What's up with that? And finally, my suggestion of sorts, or I just don't see that existing anywhere, is involvement of community, specifically in the food and agriculture space. Like a lot of traditional knowledge with tribal farmers or just localized problems that are solved by indigenous methods are great success stories, right? Like great success stories of market linkage, market intelligence, as we call it, or just climate resilience has come in from community practices. And there's a lot of leader farmers, perhaps. I know for sure of some in India who have a lot of knowledge that is even beyond uh, perhaps what academia focuses on. So you should involve such leaders, farmers, like community leaders. I don't see that anywhere. Perhaps you could take that up.
Yeah, I'll just respond quickly and then I'll let Kata talk more about EU cost. The NSF allows for-profit partners. In fact, we have an entire directorate that deals with partnering between for-profit and academic researchers. It's called TIP, which is Technology Innovation Partnerships. And their main award, Convergence Accelerators, is their big one. And Regional engines, yeah. So that's our newest directorate. It's only 2 or 3 years old. It's the brainchild of our current director. Year and a half, okay.
Government agency. Sorry, the TIP directorate is new, and because we are a U.S. federal government agency, in their first couple of years, there's a bit of pressure to deliver results that that benefit the U.S. They are looking to options for broadening engagement, including international, but it's likely to be a few years before we see that happening in any big way. Where it does happen, it is primarily at the PI level. So there's a program called Regional Innovation Engines, looking at geographic regions within the US. Those engine teams can bring in international partners, for example. Those are $160 million awards for 10 years. There aren't a lot of them, but they're huge. The biggest thing NSF has ever funded that's not a major research facility. But there, again, you could imagine you'll see bottom up not only industry partnerships, but potentially in international partnerships emerging over time. And then I would expect in the next few years, there may be a little bit more intentional effort to engage international partners and potentially industry as well.
And while Anne has the mic, Anne Amig is the head of programs in my office. Our director, Setharaman Panchanathan, has been working very closely with his Indian counterparts. And we have several kind of drawing your attention to, dear colleague letters to Indian partners. And we do have some agreements, I think, in the works. I don't know if you'd want to comment on those in terms of collaboration.
Yeah, so collaborating with India has both become an interest of the research community, of some segments of the research community and of the White House, to sort of broaden engagement with India in the basic research space. So we have concluded a number of agreements with India for collaboration in AI research and biotech research and things like that. And there are related dear colleague letters. There have been 3, I think, that have been issued in the last 6 months. So
USDA funds a lot of our national and maybe some international agricultural elements too.
that's right.
And we do in NSF, we fund a lot of projects that do exactly what you were talking about. It's primarily in the social sciences, working with local communities. But I think, you know, Michael's project is, and, you know, the Sustained Food Group more broadly, they do exactly what you're talking about. We have another AccelNet called Natura that's all about place-based solutions, working with the people collaboratively. So there's a lot of that already going on at the National Science Foundation very broadly and within our AccelNet awardees. But you may not be as aware of it, but it is actually happening. Yeah. It's very difficult to find. Yeah. Yeah.
For private sector engagement, if there was a easy, streamlined way of doing it, like the Horizon program was, I don't even know where my application is. Like, it's complicated, very complicated. And like for people like us, it's difficult to follow the process because, you know, we have to fund our own work, right? So it's difficult to do that.
Profits and academic research institutions is how we see a lot of for-profit partners coming in, and sometimes maybe doing a cost share. But I think a few of you might have had some follow-up on it. Those.
I would be happy to give the cost perspectives, and then maybe you can give comment on from how it's going from the practice, and then so we can have all the theory together. And to both of your questions, if private actors can join cost actions, and if Indian origin or Indian-based actors can join both of the question, the answer is yes. In cost actions, the best way is that you find the cost actions on the website, which are thematically related to your work, and then you can, with an easy online application, you can apply and you can join these networks without going through any hassle of applying for your own proposal. A non-proposal cannot be submitted by an Indian partner, but it can be always a partner in a proposing team. And cost is, yes, it's strongly related to the Horizon Europe framework program of the European Union, because basically cost is funded from the Horizon Europe framework program. So we get our budget from there. So that's why a lot of rules that are applicable to the framework program also applicable to cost. But our projects are much smaller, both smaller from budgetary wise, but much bigger as a network and much easier to get access. And when you have access, partner in the network, then maybe you can find also the partners that you can join bigger projects and can continue to work towards your objectives. And then.
Go ahead, Chrissy. In the meantime, I just want to say, I can give you names of a couple of international water energy food nexus projects in India, AID and the Center for Global Agricultural Systems have activities there. And then also our philosophy is bottom up, working with the farmers, not showing Western technologies. And I just want to have Abdullah talk about our entrepreneurship, getting early career researchers to do innovative activities.
I mean, if I may. I mean, in our proposal, our strategy was, how do you take that research from the lab and actually create a solution out of it and create a company, maybe an organization with that. So our strategy is actually trying to use NSF I-Core program. So we have been giving I-Core program. So we have been giving, like in our institution, training to our faculty, how they can take their research from lab into reality. So we are going to do some training on this. So we are organizing like an idea challenge We call it Zero Hunger. It's in the process right now. And the winners will take that training. But the purpose on the training is actually not only helping them to develop their ideas, but also teaching them how to go about this so that they can implement same kind of strategies or same kind of training in their institutions. So this is our strategy basically in our proposal.
Okay, so I will start by saying that I am a partner in a project called Lotus. You should look it up, Lotus EU project. It's an EU-India collaboration. And so we are doing exactly what you were addressing. So all our solutions are developed in Europe, but they're transferred to India. We work with farmers, we work with companies, we work with universities as well. And we are now signing contracts. I mean, there are contracts being signed for the mass production of a sensor that we developed within the project. So the collaboration is very active with Indian colleagues. I've been there a few times, and this is about water. It's about water and water quality, and a sensor that works in all cases. And the coordinator of that project is part of my NexusNet network. So the private sector, I will just speak now on the point of view of Horizon, is very important. So most of the innovation actions cannot be submitted without private sector. So the Commission absolutely wants to have private sector, to have companies, startups like yourself that will exploit the results of the research and will advance the TRL. So this is a prerequisite, actually. And the Horizon programs are not difficult to follow. You just go in and you just need to attend maybe a couple of info days. There is massive funding out there for solutions. And I am not sure if India can be funded through Horizon. I'm not sure about that. I mean, I know the specific programs can, but we need to look into that. But if you come in any of these cost networks, you will see coordinators like myself of other projects. So we all bring our projects there. So it's really a hub for people that are looking to link up with the private sector. We are having our annual meeting in Croatia in a couple of weeks. In 1 week, actually. And there we have an exploitation workshop only with practitioners. So we do not leave the private sector outside. We focus on that, and we want our results to be exploited. We don't do just research, at least in my network. So it's very nice to see the private sector being interested because this is where things are implemented. We know that.
Oh, did you?
Yeah, sure. Very short. Just to add, even in our nuclear astrophysics cost action, we had private sector partners to exploit the technology in the real world in other contexts. So definitely there are many opportunities.
There's a question online. I have heard the panel refer to collaborators from all over the world, and in particular from Africa and Uganda. However, I don't see representation from Uganda here unless I missed it. Is it out of disinterest or any unique challenges in involving their collaborators? I'm from Uganda, and getting to know some of their collaborators would be nice. So I'm going to answer half of that question, and I'm going to turn it over to Michael's team, who are the group that are working with Ugandans and held their first workshop there. So first of all, and I guess Kata and I didn't actually state this at the beginning, EU Cost brought 2 of their funded groups here. Which, and NSF brought 2 of our funded groups. So these are the awardees from within the funding schemes. We would have loved to have brought all of their collaborators from various places around the world, but we have a limited budget. So this is what we focused on, bringing in our PIs on the US side, who also have partners who are collaborating on the European side. And each of these teams have got collaborators. As Michael said, they focus mainly on Africa, but that network is growing. And these other groups that we've talked to, we saw, with Luciano's keynote initially, all of the different collaborations all over the world. So that's why you're seeing the people you're seeing here. They're the people we've funded in terms of the international networking. But to address Uganda specifically for our listener online who wants to make these connections, maybe you could put something in chat as well to help. But if you'd like to comment.
Yeah, sure. So I mentioned this a little bit before, but our main activity of this past year, the Collaborative Learning School, was done entirely, everything co-produced and run with colleagues from Makerere University in Uganda. So we were working there particularly with Ellen Kayandeke, who's actually a junior faculty member who spent time at Michigan State University 2 years ago as part of an exchange program. And then also Frank Kansime, who's a senior faculty member there. We also worked very closely with their extension program and other staff. And we co-designed every aspect of the Collaborative Learning School with them. We also have we're talking about like rules of engagement, rules of working together. One of our things is that we will always co-publish everything with our local partners that comes out of these engagements. So it is very collaborative. And I will just say that, yeah, the other challenge, in addition to budget, obviously, for bringing everybody across the ocean for these things is visa. And we've had real challenges with visas for our African partners in the past couple of years because of the backlog from COVID. And we actually wanted to bring them all over here to the US last year for a kickoff event and weren't able to because of visa. So yeah, so there are, limitations beyond our control sometimes to whose face you see. But yeah, it's co-produced. If you want more information about how to get hooked into our network coming from Uganda, though, just ping us afterwards. I think our contact information is in the materials.
I just want to add, Uganda came up because we just did a 2-week event there, but last December we did a mini collaborative learning school in Zimbabwe, and we plan to do 4 more in other parts of Africa. So it's not like that. And also in Uganda, we brought Africans from 6 different other countries to this collaborative learning school. So it's not just EU, Africa, Uganda, one country, and US researchers. It's trying to be inclusive, and hopefully those people who attend these things will expand our networking.
So since I'm the only African on the panel, I'm from here too. Okay, I'm from Kenya, close enough to Uganda. But the thing I was also going to say that from a cost effectiveness perspective, it's easier to engage more Africans if you do it in an African country. Yeah, how many people from Penn State went? We were 6 people from, 4 people from Penn State, 3 people from Michigan. So if you count, if we were to share the numbers, the composition of the group, you'd see what we mean, that by doing it in an African country, we increase the number of participants from African countries who are in the group, as opposed to, which we are still going to do, bring them here. When we bring them here, the number ends up being a little lower because of all the challenges that my colleagues have shared, including the visa issues. Thank you.
Very briefly, one of the things that I think that everybody has in mind, but is not applied, is respect. Is respect to the other people. And that is one of the most challenging things that we do have, especially in our South, guys. Within Europe, outside Europe, respect. And this is things that is not applied. We all have in our mind, but we don't apply. When you have to come through and we have to go to the result, we don't apply. And this has to change dramatically if we want to overcome the challenge. That's my personal opinion. Boo! Working in different places, like me, for example, I like working in Brazil, working as a professor too, looking other, traveling a little bit, if it is now not CO2 friendly, knowing each other, having a beer, which I couldn't have yesterday, nor on Wednesday, because of the acting word. But that's the point. And I love making this cost action and Horizon another project, because most of the people during the last 20 years is friends. They are friends. And it's difficult, I know, but it's the only way. And it's necessary, because time is running out.
So thank you very much for all the questions. I just a last check if there is any more questions remaining with someone, either online or in the room. to see no one leaves with any unanswered question. And if not, then we are really very happy to have you all here today on site, online. And also the event is recorded, so it will be available for those that couldn't join us, though expressed their wish to be with us today. And thank you very much, especially to the panel, all of you for your time, and Luciano for the keynote speak, to be here with us and spend the time. Thank you for the support from the NSF AccelNet program for Cara, and thank you, Anne, for making the time to be with us, and also to the CUNY colleagues who set up this nice room, and with all the needed equipment to have this event here organized. And we wish you a good continuation, collaboration, and a lot of projects and result coming out of it. And maybe also a beer this evening. Thank you very much.
Thank you.